Okay, so you guys graphed 2 equations per graph. So the first equation, I didn't really need to show much work because y equals x squared is the parent function. So I just graphed my parent function. And then y equals x plus 2 is just the y equals x line, but shifted up 2. And then I copied this with a copier. It didn't copy very dark. Just fixing that real fast. Okay, what today's lesson is called systems of equations, which we've actually done before. We did systems of equations where you have to solve by elimination or substitution. We've done that before. We've also done systems of 3 variables with 3 equations. Remember that? It was your favorite, remember? Well, we're not doing 3 variables. We are going to do 2 variables today, but today we're starting to do systems of nonlinear equations. So you'll see that at least one of these is not a line. Okay, so when we solve systems and when we did this before, does anybody remember how we write our answers, our solutions? When we did the 3 variable systems, how did we write our solutions? X, Y, Z. What was that called? An ordered triple. And if we find the solution on an X, Y axis, then our answer is going to be an ordered pair. Thank you. Excellent. Okay. So look at this graph. What ordered pairs do they both have in common? How many ordered pairs do they have in common? Read. How many ordered pairs? 2. Can you tell me one of them? Well, it should be on your paper. Emma, can you tell me one of them? -1, 1. She's thinking maybe -1, 1 is the solution. And Timothy, can you tell me another one? And Timothy's thinking 2, 4 might be another solution. And when I say they're thinking that, I'm kind of giving you the impression that it might not be the case. Am I? Okay. What would happen if I don't know, make a silly mistake and graph it wrong? You wouldn't have the right answer. You graphed it wrong. Okay? You might find where the 2 cross, but if you graphed it wrong, you're going to have the wrong answer. So we have to graph these equations. We have to find where you think they cross, but we have to verify that. We have to make sure we're right. And if we are wrong, then we have to go back and figure out why we're wrong. So you're going to be checking your solutions. That's how we're going to check our solutions. Do you have some space for this one? Okay. So we're going to check. I'm going to first check the ordered pair, -1, 1. I'm going to check that. To check it, it has to work. It has to be a solution for both equations. So I'm going to plug in -1 for x and 1 for y in both equations. So 1 equals -1 squared. So 1 equals 1. Does that check? Yes. The other equation. 1 equals -1 plus 2. So 1 equals 1. Check. Oh, hey, tell me it's fuzzy. Come on. Now can you see it? Just kidding. Oh, what's going on with you? I thought I could see all the time. Yeah. Are we good now? Okay. So you have to check that equation, and since it worked in both equations, guess what? That one is right. Let's check the other one. So now we're going to check 2, 4. We check it in both equations, so I'm going to put in 4 equals 2 squared. So does 4 equal 4? Yes, check. The other one, 4 equals 2 plus 2. Does 4 equal 4? Yes, check. So what does that tell me? It checks. What does that tell me? It's a solution. It's right, yeah. So now we're going to list our solutions. Just getting another color. Ooh, I like this one. We're going to list our solutions as a set of solutions. A set of ordered pairs. There's more than one, so I'm going to put them in fancy brackets separated by commas. So we're going to start out today by, you have to solve by graphing. That means you have to graph both of them, figure out where you think they cross, check your answers. So let's pick another one. Question B. Question B. Look at the graph for question B, which you guys graphed for your assignment. Mine's kind of light. Where do you think there is a solution for question B? David. David thinks -2, 0. Matt, where's another one you think?
Not sure.
What are the two graphs cross?
-2, 0.
Oh, we did that one. Kind of light, but I did that one. So where else do the two graphs cross? The line in the parabola. Two, four. How do I know for sure? We have to check it. So let's check -2, 0 in both equations. I really don't have a ton of room here, so it's going to be squeezed in over here. I'm going to use -2, 0 first. I'm going to check it in both equations. So I'm going to start with 0 equals -2 squared plus -2 minus 2. So I'm checking it in the first equation. If you have to check more difficult numbers to plug in, like this one's not difficult, I could do this by hand, but if you did need to check more difficult ones, just make sure you put the parentheses in where they go if you're using your calculator to check them. Otherwise, it's not going to help you if you don't know how to plug it in your calculator correctly. So I got 0, and that's what I wanted to get. 0 equals 0, check. Then I have to plug it in the other one. So y is 0 equals x is -2 plus 2. Does that check? 0 equal -2 plus 2? Yes. All right, then I got to check my other ordered pair. So 4 equals 2 squared plus 2 minus 2. So 4 equals 4 plus 0, so yes, check. And then the other one, 4 equals 2 plus 2. Yep, that checks. So how do we write our solutions? Fancy brackets. Where can I write it? I'll write it over here, I guess. Fancy brackets. List my ordered pairs, -2, 0, and then 2, 4. There's my answer. So as long as you remember how to graph, you should be able to find these answers and check them, okay? Let's go through where you think the solutions are. We're not going to spend all day just checking them because you're going to do that on your own with the homework. I just want to go through where you think the solutions are and check your graphs. So the next one for C, look at my graphs. Did that without a straight edge. Sorry, it's a little wiggly. Where does it look like they cross? -2, 3. You guys agree? Did everybody have the same graph, or do you think Miss Criswell maybe graphed it wrong? Do you have the same graph? We're not going to take the time to check these. We're just going to go through them. And then what about this ordered pair right here? 3, -2. Does anybody know what order I'm putting my ordered pairs in? I've done it the same every time. Yeah, from the graph, it's just left to right, the same way we read, left to right. That's the way I'm writing them. All right, here's D. You should get these fun little graphs that intersect twice. Got an ordered pair right here. Shay, where do you think that this graph intersects? 2, 0. And Stuart, are you looking on my graph or your graph? -3, 0. Okay. So we write our solution. Once we check it and we know that it is correct, which of course is correct because it's me, right? Okay, I'm just joking, guys. And then 2, 0. We write in our fancy brackets, left to right. Okay. How many solutions does it appear that E has? Just one? Is that even possible? Yeah. Where do you think? Where do you think it is? 1, 0. So that one, you'd only have to check the one ordered pair in both equations. That's not bad. I wouldn't need fancy brackets for one answer, but it doesn't hurt. So I don't forget them for the others. It doesn't hurt, but I don't need the fancy brackets for one answer. How about F? Jacob, you see one of them? Zaina, you know the other one? Chyla? Jessica? Is that a little harder to tell? Because what's wrong with trying to find answers by graphs sometimes? Okay, so I might not be perfect graphing it. Maybe. Just kidding. What'd you say? We can't use a straight edge, so it isn't really all that accurate. Does it always hit exactly at integer points? Or do you think maybe this one might be a fraction? That could happen. So I don't think that finding answers by graphing is the most effective way of finding answers. So there is an answer, and it isn't a horrible answer, but I'm going to show you another method. It does involve graphing, but it involves our graphing calculator. Okay? So go ahead and pull out your graphing calculator, go to y equals, and type in the two equations. Now, I'm going to teach you a method that you can use when I say you can use the graphing calculator. This should not be the method that you always use, because it's not going to always help you. But it would definitely be something good to know for like a ACT, where it's like a time test and you don't have time to graph this by hand, and or use one of our other methods that we're going to learn today? Oh no! No! Next time, just run up there. Next time, just run up there. Oh, and I typed in my thing wrong. Hopefully my video is okay after that. Looks like it's still going. Okay, so when you hit graph, if your window is all funky, hit zoom 6. If it's all funky, you can hit zoom 6. If you are not having graphs that look like mine, if you're having any errors happening, tell me before I keep going. You didn't type it in right. Go back to right. You didn't do it. So we're going Who else? Anybody else having issues? Okay. Ready? I'm going to teach something that's really helpful. It's really helpful. Here we go. To find where the two graphs intersect. To find where the two graphs intersect. By the way, would I reteach this to you on a quiz or a test? So if you jot down a couple notes, that may be helpful for you. Okay. I'm going to go to my calculate button up by the graph, and I'm going to do second trace, and I'm going to look at the choices. I've done something dirty. Sorry. Go to right. Get the plot on. You got to go up there and turn it off. It's going to take me 1 moment to fix this. Okay. All right. So we're under second trace, and you look at your choices. Which choice is going to help me find where the two graphs intersect? 5. Push 5. What were you guys doing here? I'm fixing hers. She's the same problem. I don't know what you guys were doing. It did something. Huh? It is. It is. I just got to go find it and make it quit. I think I fixed on yours. All right, one more moment. I'm sorry. You quit playing with your apps and fix it for you. You're about to die, too. I mean, you're. And then that sounded horrible on video. Please don't very bad. Okay. Her battery's almost dead. Okay, so we're at second trace. Second trace was just calculate and then intersect. Are you there? At the bottom it says first curve. Now, if you have a color one, I just heard this yesterday, so I learned it yesterday. If you have a color one, you can see by the color which graph it's sitting on. So mine's blue, and the first curve. If you are having a problem and you're not asking, I'm going to keep going, and then you're going to be even more behind. Okay, so I'm on the first curve. If you don't have the color calculator, then you're just going to have to make sure that your little cursor is sitting on one of the curves. Then hit enter. Then it says second curve. Now you just have to make sure that your calculator little cursor is sitting on the other curve. If you can't tell because of where it is, just move it left to right. Oh, also if you can't tell, there's the equation at the top too. Okay, but now I can tell mine's on the other curve, so I'm going to hit enter. And then it says guess. Now this is the important part, so continue to listen. When it says guess, you have to tell it which intersection you're trying to find. And you're going to type in the X value that is closest to that intersection. So I'm going to find the one on the left first, which we've already found, but I'm going to find it on the left. So I'm going to choose what X value? About negative 1. Okay, so type in negative 1 and enter. If you've done all that, at the bottom it'll say intersection, and it'll tell you the real place that the intersection is. Now you can't get more than one at a time, so we're going to go back through that to get the second one. Are we ready to try the second one? No? So I'm going to go.
So after we enter on both of the curves, what do we press? So
What does it say at the bottom?
just numbers 0 to 5.
Does it not say words like guess?
Yeah, it does say yes.
Okay, it says guess.
Yeah.
That's what I mean.
Sorry.
Type in negative 1, enter. So I picked like the x value that's close to where I think they cross.
Okay.
Okay, same thing again. Second, trace. Intersect is 5. First curve, because I have the color calculator, I can see I'm on the blue one, but if I couldn't tell, I'd just move my cursor to the left a little bit. Now I can tell. And then my red one, enter, and then guess, this time, what x value does it look like it's close to? 1? Okay. So we'll type in 1, enter. And it tells me the intersection's actually at 0.5 to 0.25. So it told me we're at a fraction. A half, 2 1/4. So that would be my second intersection, yes. No, you don't have to, but I like that method better in the long run. So I want to keep reinforcing that method. But you can just like click. The problem you'll have is if you don't actually go close to the one you're trying to get, it'll keep telling you the other one and you'll get frustrated with it. Okay. All right, so now we know how to do it on the calculator. We will come back to this calculator method a couple times throughout class. But I will tell you that the calculator method will not always work. You know why? Because if you have a solution, I'm just going to come up with the solution. I'm just making this up. If where the x is if my ordered pair was, I don't know, 3 plus square root 4, comma, 9 minus, that square root 4, what am I doing? I meant square root 5. Okay. 9 minus square root 7. If that was the ordered pair, what the intersection, calculator's not going to tell you square roots. It's going to tell you the approximate decimal. So you'd be out of luck because you couldn't find it. So we cannot 100% rely on the calculators. We need to know it other methods. Could I graph it and find this answer, you think? If I looked at a graph, would I know that it was at 3 plus radical 5? So we need another method. We need another method. So the packet that I've handed you is the other method. So let's go to those notes. And I'm going to skip the warm-ups because we did the graphing already for our warm-up. I'm going to go straight to just some vocabulary real fast. You see where that is right in the middle of the front page? We're doing systems of nonlinear equations, which means at least one of the equations is not a line. So this first equation is not a line. What does it make if it has an x squared? Quadratic. It's a parabola. The second one is a line, but that's okay. If one of them is not a line, it's not linear. Then there are different solution choices. If we have a quadratic and a line, you could have no solution. It wouldn't cross. You could have one solution. You could have two solutions. If you had two parabolas, you could have no solution. You could have one solution. You could have two solutions. Okay? Example 1 says solve the system by graphing. We just practiced that, so we're going to skip example 1 because we've already practiced solve the example, the system by graphing. So we're going to jump to example 2, which says solve the system by substitution. So we are now reviewing substitution, which we did in chapter 1. So substitution, first you have to have one of the equations solved for one of the variables. Now I'm going to give you a hint. When we have these nonlinear ones, let's try to get one of these equations solved for one of the variables that doesn't have a squared in it. So we look at these variables. Which equation doesn't have a squared? I'm sorry, I lied. Which variable doesn't have a squared? Y. So I'm going to pick one of these equations to make y equals. Which equation, equation 1 or equation 2, would you like to make y equals?
2.
Sounds good. Let's do that. So to make it y equals, I'm going to subtract the x. We get y equals, I'm going to write it as 4 minus x. You could write it as negative x plus 4, your choice. Now what we're going to do with this is we're going to substitute what y equals into the other equation for what variable? Y. Put it in for y. So the only thing I'm going to substitute is the y. All the rest of equation 1 is still equation 1. So my equation 1 now looks like this. X squared plus x subtract parenthesis 4 minus x. Close parentheses, equal sign, negative 1. So wherever the y was, I put parentheses and put what y equals. And those parentheses are important because what's outside of the parentheses? What's that negative going to do? Yeah, distributes in, and it changes all the signs. So now my equation is x squared plus x minus 4 plus x equals negative 1. And we've got, by the way, if you're writing really big, probably going to run out of space. We've got a few x's over here. Are there any like terms we could combine? Okay. So what is an x plus an x? 2 x's, right? So x squared plus 2x minus 4 equals negative 1. I'm going to pause there and just double check we're doing this right. We have to solve for an equation or for a variable, and to solve for the variable, it can only be that variable in the equation. I can't have x's and y's in the equation. So we just want to make sure, do we only have x's? Okay, because sometimes people substitute wrong and make mistakes, but you can only solve it if it's just x's and y's, which right now we're good. All right, we have just spent some time learning how to solve equations that have x squared in them. What is a method that you know to solve the equation when it has an x squared? Factor it. What else? Square roots. What else? Complete the square. What else? Graphing. What else? Quadratic formula. 5 methods. I think we're going to today. We are going to. So I personally, if I can factor, that's my method of choice because it's the fastest. So if I can factor, I'm going to. But in order to solve it by factoring, it has to equal something. 0. If it doesn't equal 0, don't start factoring. So in order to solve by factoring, I have to move that 1 over. Once it equals 0, I'm going to see if this factors. So this is a trinomial. There's no greatest common factor. So I'm going to go straight to guess and check. I know x times x is x squared, so these are definitely going to be x's. I'm looking at my signs. This last sign is a minus 3, so it's got to be a plus and a minus. It's a 3. So what numbers do I have to pick from? Sure. What numbers do I have to choose from if it's going to be a 3? 3 and 1. I just got to figure out where to put it so when I multiply it back together, I get a positive 2. So I'm going to put the 3 here, the 1 here. We can check it. 1x minus 1x plus 3x. Yes, that works. Okay, I factored it correctly. So it factors. I'm going to move on. And you guys know, like, when you actually do it and you know how to factor, it takes way less time than me just explaining all that. Okay. Now, once I have it factored, how do I solve How do I solve for x now? You put x plus 3 equals 0. X minus 1 equals 0. You set each factor equal to 0. And we get x equals negative 3 and x equals 1. Excellent. Do we have what we're trying to do, or do we have it solved what we're trying to do? What are all my answers going to look like? What am I trying to do? I'm trying to find where two graphs cross. What are all my answers going to look like? An ordered pair? Do I have an ordered pair? What do I have? I got two x's. I still need two y's. Well, maybe you would prefer graphing instead. So to find y, we're going to have to plug our x's in to one of the equations. When you look at your two equations, which ones would you like to plug these x's into? Okay, let's plug in 2. This should sound familiar, like we've done this before. Okay, I don't remember the equation. X plus y equals 4. Thank you. So we're going to do negative 3 plus y equals 4. So y is 7. That's one of them. The other one we're going to do 1 plus y equals 4. So y is 3. How do I know I didn't make any silly errors? Because we're going to check our answer by checking it in which equation? No, we just plugged it in. Oh, yeah, I'm sorry. You're right. I forgot we plugged in 2. Yes, we're going to check in 1. Sorry, my bad. You're going to check in 1, but we got to check each ordered pair. So the first ordered pair is going to be negative 3, 7, and then the other ordered pair is going to be 1, 3. We're going to check each of those in equation 1, which I don't remember. X squared plus x minus y equals negative 1. X squared is negative 3 squared plus x negative 3 minus y 7 equals, what, remember? Negative 1? Negative 1? Yeah. Okay. So I've got 9 minus 3 minus 7 equals negative 1, so that's negative 10, or 9 minus 10. Yes, that equals negative 1. Check. All right, almost there. And check the other ordered pair, which is 1, 3. So I'm going to have 1 squared plus 1 minus 3 equals negative 1. So 1 plus 1 minus 3, 2 minus 3, yes. So our ordered pairs are negative 3, 7, 1, 3. We will be doing 2 more examples before we have our brain break.
Like, how do you know which x goes with which?
Because what did I plug in? This is a very good question. How do you know which x goes with which y? Because when I look at what I plugged in to find the y that was 7, what did I plug in?
Oh, negative.
The one that goes with it.
Okay.
Yeah. So just stay organized with your work. You can check it on the graphing calculator, which we're not going to take the second right now to do it, but you can check it on the graphing calculator the way I was showing you to do the intersections. Okay, the next example we're going to do is solve by elimination. Elimination is where you would add up the two functions and completely cancel out either all the x's or all the y's at one time. So we look at these two functions. I've got 4 total terms with x's, but I only have 2 terms with y's. I think it's going to be easier to eliminate y. If I add them the way they are, what were we going to say? If I add them, they're already set up to cancel, correct. Now, if I needed to multiply something, like if they were both positive, I'd have to multiply one of them by negative 1 to get it to cancel. But this one's already set up for us, so let's add the two equations together. 3x squared minus 3x, y's eliminate, equals -2. I like elimination because now we're ready to start solving. If there's an x squared in it, I'm going to see if I can factor first. So I'm going to move the 2 over by adding it to both sides. I'm going to have 3x squared minus 3x plus 2 equals 0. That's a trinomial, so I'm going to see if I can factor. Is there a GCF? No. So to get 3x squared, it has to be 3x and 1x. It has to be. To get a positive 2, they both have to be the same sign. To get a minus in the front, what sign do they both have to be? You can say anything. I do the same thing for you. What signs do they have to be? They got to both be negative. Now I just got to figure out where the 2 and the 1 go to make 2. So guess and check. I'm going to say 2 here, 1 here. Okay? Multiply back together, and I get a minus 3x, and I get a minus 2x. Does that add together to give me a minus 3x? Nope. Okay, I got it wrong. Good thing I can erase. I'm not using a pen. So I'm going to try the 2 and the 1 here instead. So minus 6x and minus 1x. Does that equal negative 3x? What did I do wrong? Why can't I factor it? Oh, because not everything factors. So instead, what can we do? Because this is not going to factor, we got to use something that works every time. We can do complete the square, or we could do the quadratic formula. Reed, what would you like to do? Excellent. Let's do the quadratic formula. You guys ready? I'm going to first write the formula just so we can sing the song.
Ready.
All right. Don't leave me by myself here. Ready? 1, 2. You want a solo? I'm sorry. Did you want a solo? Okay. 1, 2, 3. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. I was looking. So now let's plug stuff in. We've got x equals opposite b plus or minus square root 9 minus 4 times 3 times 2 all over 2 times 3. 3 plus or minus square root. I need to do 9 minus 24. Help me out. 9 minus 24. Negative 15. Thank you. Over 6. And I'm going to stop for a second. What do I do when there's a negative under the square root? So I'm going to pull out that I, and I'm going to have 3 plus or minus I radical 15 over 6. What is our goal? To find where these graphs intersect. I'm trying to find the ordered pairs that they have in common. I just found that x is imaginary. Is that going to show up on a graph? So there's no real solution. Exactly. This would be 2. Were these both parabolas? I can't remember. Yeah, they're both parabolas, right? Both. Yeah. So these would be 2 parabolas that don't intersect. So we just write no real solution. Okay, so if you get negative under your radical, no real solution. Okay? if you graphed it on your graphing calculator, you would also be able to verify that you were right. Oh yes, I didn't make any silly mistakes. There is no solution. They don't cross. Okay, before our brain break, you see those 3 questions at the bottom? You have to pick one and do it correctly and get a check, and then we'll take a brain break. You pick which one you want to do. Okay, can we go to this page here? Because we're going to actually do stuff with circles too. I hate circles so much. Oh, stop. It's life. And circles, that's circles. Circles are very important in math. And we've got the equation of just a basic circle of x squared plus y squared equals r squared. What is r? Radius. With a circle and a line, we could have no solution. We could have one solution, and we could have 2 solutions. Okay, geometry people. What's that called? Tangent. Good job.
So one thing I learned that.
The one thing. Such an important thing to learn. So example 4, we're going to solve this system. In order to use elimination, we have to add up and completely cancel out all the x's or all the y's. Not going to happen here. Because on top they're squared, on the bottom they're not. You can't add that. So you can't use elimination. We have to use substitution for this one. You also can't use the graphing calculator because you can't graph the circle. You can, but I'm not teaching you yet how. But anyway, I will later. So we're going to use substitution. So, and this is nice. Y is already equal here. Y equals negative 3x plus 10. So I'm going to replace y with negative 3x plus 10. I am not replacing the squared part. I'm only replacing the y. So I'm going to rewrite that as x squared. This is equation 1 I'm going into. X squared plus parenthesis. Negative 3x plus 10, close parenthesis squared, equals 10. So I replace equation 1 with equation 2. Substituted. Now we're going to have to solve do not kill a puppy. We are now going to solve for the variable that is left over, and we see it's all x's. So we're going to solve for x. Do not kill a puppy, though. What am I talking about? Yeah, I know. So what should I do to square that parenthesis? Kyla? Is that not what you were raising your hand for?
I didn't hear. I don't know that.
Let's see if you know the answer. Kyla?
I didn't hear the question.
I'm repeating it. How do I square a binomial?
You multiply by itself.
I need to first write it twice, and then how do I multiply a binomial times a binomial? Foil distributive property, yeah. So we're going to have x squared, it is same thing, plus negative 3x plus 10 times negative 3x plus 10 equals 10. So we need to use our FOIL method, our distributive method. We're going to have negative 3x times negative 3x is 9x squared. My outside and my inside are both negative 30x, so minus 60x. Oops, 60x. And then my last is plus 100 equals 10. Okay, once I've FOILed that out, I need to combine like terms. And we've had to do this on the other ones too. I might as well make it say equals 0 at the same time. So I'm going to combine my x squared with my 9x squared, so 10x squared minus 60x plus 100. Nope, not 100, I lied. Plus what? 90, because I'm going to subtract that 10 over equals 0. We have to solve this. There's a squared, so we have all 5 methods to choose from, but personally, if I can factor it, I'm going to try to factor it. So let's see if it factors. What is my first step of factoring? Is there a greatest common factor? 10. Now, x squared minus 6x plus 9. Two parentheses. Start with x and x. What are my signs going to be? Two negatives. Yeah. How do I multiply together to give me 9, but adds to give me negative 6? 3 and 3. So I really have 10 times x minus 3 squared equals 0. So I'm going to actually like the square root method now. Right now I'm going to divide both sides by 10. So I'm going to get the squared by itself. I could continue to do this by factoring, but it's good to practice different methods. So. What's 0 divided by 10? Oh, that's good. So then I'm going to square root, since this entire side now is squared, I'm going to square root. And if I square root, remember I have to put plus minus. So I have x minus 3 equals plus minus square root of 0. Here. So x equals 3. So how many solutions am I going to have? Is that it? What am I actually trying to find? Like if I graph this, it's where the circle and the line intersect, meaning I need an ordered pair. I need a x and a y. So I'm going to have to plug that in. Which equation, 1 or 2, would you like to plug into 30? 2. Yeah, let's plug it into 2. We're going to plug in, so y equals negative 3x plus 10. So y equals negative 3 times, what are the 3? Plus 10. So y equals negative 9 plus 10. So y is 1. This is a lot of math. How do I know I didn't make any silly mistakes? How? Plug in 1. X squared plus y squared equals 10. So x squared was 3 squared. Plus y squared is 1 squared. Has to equal 10. 9 plus 1. Check. Answer is 3, 1. See, there's 2 equations, 2 examples down there. Everybody do number 4. Sorry, I didn't give you choice that time. Everybody do number 4. Everybody's trying number 4. Mm-hmm. No, you're not. Well, where did your shoe go? But if you took out an X, that shouldn't still be square. Oh my God. have a mistake. When you FOILed originally and you did 4 times 4, you wrote -8. I have part of it on the board. So these should both be X's. Okay. Like, how did you get this? Oh, you have, okay, there's a second. 2 solutions. So you have one. So I, on the board, FOILed, and you might want to check after you FOILed and combined like terms to make sure you did the FOILing part right. Because if you didn't do it right and you work from there, you're going to get it wrong. So I FOILed everything out, I combined like terms, I made it say equal 0. If you are at the same place that I am at, I'm going to explain my next step. You should be able to do it by any of your methods that we've learned. Yes. But I personally like factoring. So I look at my 2x squared minus 8x equals 0, and I say, is there a GCF? 2x. So I'm going to factor out that 2x. I'm going to divide it out, and I get x minus 4 equals 0. So I used factoring. Now I have 2 factors. Set both factors equal to 0. I'm going to put it over here. 2x equals 0, and x minus 4 equals 0. So when I solve this one, I get x equals 0, and the second one, x equals 4. So I have 2 x's. That means I'm going to have 2 ordered pairs. What do I have to do with those x's? One at a time. Plug them into one of the original questions to find the y. Which one should I plug them into? Yeah, I'm going to use 2. So I've got y equals negative 0 plus 4, so y is 4. Y equals negative 4 plus 4, so y is 0. How do I know it's right? I'm going to check them in one. X squared plus y squared equals 16. So I'll do 0 squared plus 4 squared equals 16. Yeah, that checks. And I'll do 4 squared plus 0 squared equals 16. Yeah, that checks. So we have 0, 4, 4, 0 for our solution. I'm going to do one more kind of examples, and it's on the back. And it's graphing calculator. So this last kind is solving an equation by graphing. It's solving an equation by graphing. You'll see that in all of those examples, there's no y's anywhere. Do you see? They're like all x's, aren't they, in your examples? So when you're solving this would be just solving to solve for x. And we could move all the x's to one side. You don't need to do this, but you can if you want. I'm not going to finish this one. We could like move all the x's to one side. Oh, look, that looks like one we already did. Then we could solve for x by factoring, by quadratic formula. You know, we could solve it. But this is only asking us to solve for x. It is not asking for an ordered pair. But I'm going to do it the same way that I did the ordered pair kind. I'm going to do it by graphing on my calculator. Okay? So this equation right here, let's go to our graphing calculator. And the way you're going to type it in is you're going to type in each side of the equal sign as one of the y's. So you make just y1 that side and y2 this side. Okay? And mine's not going to be up here because I'm going to do it on my calculator. It's just make y1 one side and y2 the other and plug it in your calculator. I probably need the equations. When you look at these graphs and you say, how many solutions am I going to get? 2. Now we're going to find those solutions by using the intersect button I showed you earlier. So second trace, intersect, and it says first curve, second curve, and then guess. I'm going to guess -1. And it's not exactly -1, it's a decimal. So since we are allowed to use our graphing calculator on this last section of tonight's assignment, you're going to approximate it to the nearest hundredth. But remember, I'm only solving for x. So I'm only looking for x is approximately -1.18 for my first answer. -1.18. That's my first x. Rounded to the nearest hundredth. I'm going to go do the process again to find my other spot where they cross. So intersect, first curve, second curve, looks like about 0.5. And it's not, it's close. Approximately 0.43. Approximately 0.43. It's not an ordered pair. I'm not putting it in parentheses. I'm putting it in fancy brackets because it's a collection of answers. Those are just the x's that make that equation, those equations equal to each other. Right? Is this correct? Did I do it right? Oh, I don't think I solved it right originally. I think this was a silly mistake. I was thinking to myself, that can't be the answer. It's because I solved it wrong before. I'm going to embarrass myself too much there. Let's pick another one. Which one on this, out of these examples, which one looks like really complicated, like you would not want to solve that by hand? Which one? Which, B? Can it be B? Okay. So let's type in B, 2 equations, and let's find where they intersect, and just the x value is going to be our answers. So when I graph it, it's, oops, off the screen. When I graph it, it's kind of hard for me to tell how many solutions there are. So if you wanted to zoom in, you could do zoom 2, which is zoom in, and then you have to hit enter, so it actually does the zoom. And then it'll regraph them closer. Oh no, it looks like it only crosses once to me. So let's find where. So we do second trace, intersect, first curve, second curve, guess. Told me my intersection is 0, 0. So what is my answer for this equation? What would I write for my answer? Tim? What 0? X equals, because that's what you were trying to do. You're trying to solve for x, so x equals 0 is what you write. Even though the ordered pair was 0, 0, we didn't have any y's here, so you're only solving for x's. Okay, so you have about 11 minutes. You only have to do 3 graphs, and then the rest of it's like this other kind. There's books over there on the side of the room. Let me stop the video real fast.